In this video, we're going to learn how to name our hydrocarbons. So this is going to be a third set of naming rules. We already know how to name ionic compounds and covalent compounds. Now, hydrocarbons are covalent. We're sharing electrons. However, they have a special naming system. So here's an example of a relatively complex hydrocarbon. It's actually small on the scale of things, but it's more complex than what we've seen so far. And look how complicated this name is. Okay, I'm not doing this to scare you. I'm just showing you that it can get complicated very quickly. So we are going to keep it down to the very simple hydrocarbons, and we're only going to name ones that have straight carbon chains like we drew originally, not branches. So again, we're going to have prefixes like we did with covalent, but this time their prefixes are equal to the number of carbon atoms. Okay, so there's not going to be any indication in the name for the number of hydrogen atoms. We can always figure that out. All the name's going to tell us is the number of carbon atoms, and then the ending for the name is going to tell us if it has all single bonds and it's an alkane, if there's a double bond, an alkene, and if it's a triple bond, it'll end in Y for the alkyne. If you do have an alkene or alkyne, you will have to say the location using a number. And the key here is that it's always the smallest number possible. So you're going to have two directions you can number your carbon chain. You're always going to choose the one that puts the double or triple bond on the smallest number. Then for double bonds, you're also going to have to indicate if it's cis or trans. So that's something else to keep in mind. So here's a couple examples. This first example, we have an alkane. Everything is single bonds. If we count our carbons, we have 1, 2, 3, 4, 5, 6, 7. If we look at our prefixes, the prefix for 7 is hept. Because everything is single bonds, it's going to end in ane. So the name for this is heptane. If we look at the second example, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. The prefix for 8 is oct. This time there is a double bond, so it's going to end in ene, so we have octene. Remember, with double bonds, we have to give it a number. So I'm going to number both directions and show you the right number. So left to right, there's our 8. If I go the other direction, there's the 8. So the red way puts the double bond starting on carbon 5. The blue direction puts the double bond starting on number 3. So we're going to pick 3. Then we also need to decide if this is cis or trans. So if I look at my double bonds, I have carbons on the same side, which makes it cis. So there's your name, cis-3-octene. And do know that the cis and the number can flip. So we could also say 3-cis-octene, and that would be correct as well. All right, if we look at the next example, we've got 1, 2, 3, 4, 5 carbons. The prefix for 5 is pent. So we have a pentene, ene because there's a double bond. With double bonds, we have to number. So if I go left to right, it would put the double bond on number 3. If I go right to left, it would put the double bond on number 2. So I'm going to use that lower number, which is 2. So we've got 2 pentene. And if I check the cis and trans, I have carbons on opposite sides. So that will be trans. So trans 2 pentene. Then for the last example, we've got 1, 2, 3, 4, 5, 6, 7 carbons. So the prefix for 7 again is hept. So we've got heptyne this time. So YNE because of the triple bond. Again, we need a location. And here it's pretty easy to see that the triple bond is further to the right. So that's where I'm going to start numbering. And it puts the triple bond starting on number 2. So we've got 2 heptyne. And triple bonds don't have cis or trans because they are linear. So 2 heptyne is the final answer. Here's a few going the other direction. So we're given the name, and I'm asking you to draw the structure using line angle. So go ahead and give this a shot, see what you can do. Pause the video and come back and check your answers. All right, so the first example, we have 3-heptine. So hept is 7 carbons, and YNE means there's a triple bond, and that triple bond starts on carbon number 3. So I'm going to start with that triple bond, and I know it starts on number 3, which means the other carbon has to be 4. I need 7 total, so 4, 5, 6, 7. The other direction I need 2 and 1. So there would be a 3-heptine. It might look a little different, but as long as you have the 7 carbons, your triple bond between 3 and 4, you should be good. Next one, we have 2-cis-hexane, which is a typo. We can't have cis with an alkane, so make this an alkene, hexene. Sorry about that. So hex is the prefix for 6. With cis, I like to start with that cis double bond and make sure the next carbons are on the same side. So this is 2 and 3, which means this is 1, so that side's done. Here's 4, and then 5 and 6. So there would be an example of 2-cis-hexene. Nonane, we have 9 carbons. It's an alkane, so everything is single bonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 3-trans-octene, we've got 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. There's a double bond starting on carbon number 3, going to 4, and it's trans. And if you draw things in the zigzag pattern, you will automatically get trans. Again, you're not going to have to draw structures for us. It's more about reading them, getting a formula, connecting them to names, not so much drawing them out.